This is a web app. This is a web app. This thing here, also a web app. Dude, why am I doing this again? I built the same app 10 times with 10 different frameworks using 10 different programming languages. It was a horrible experience, but I learned a lot and I figured out which Fullstack framework is the greatest of all time, which will be revealed in dramatic fashion at the end of this video to maximize the watch time. On this journey, you will meet 10 different server-side frameworks like Rails, Django, Laravel, Spring, .NET, Next.js, Phoenix, Rocket, Gin, Vapor, and Ktor. I realize that's 11, but you don't need to be good at math to be a programmer. This video was insanely difficult because each one of these frameworks uses a different programming language. For each one of them, we will look at the overall developer experience, including things like setup, routing, database integration, and the overall architecture. Now, before we get started, here's a warning. The framework you choose by the end of this video is going to dictate your life for the next 10 years as you grow your startup into a Deca unicorn. If your startup fails, it's 100% because you didn't choose the right framework.
Reminds me of when my dad made me choose which of my pet calves to slaughter with my own hands for my 6th birthday.
Now, before we look at the code, let's first answer the question of what does a web framework actually do? There are 3 main things you should know. First, they provide an abstraction over your relational database. They typically have a built-in object relational mapper that can migrate code from your preferred programming language into SQL code that can be used by the database. Second, they provide routing that can map a URL in the browser to code that you want to run on the server. And third, they provide a way to dynamically insert data from your database directly into HTML for the UI. Together, these 3 elements make up the Model View Controller Architecture, or MVC, which is by far the most common approach when building a full-stack web app. The first framework we'll look at is Ruby on Rails, made famous for building some of the biggest companies in the world, like Shopify, Airbnb, and GitHub. Rails was revolutionary when it came out because it dramatically simplified web development compared to other approaches of the day. It's still very popular in 2022, and is kind of a rebel in the web development space. It has adjacent libraries like Hotwire, Stimulus, and Turbo that take an HTML-centric approach to building web apps, which goes against the approach you might see in front-end frameworks like React, Angular, and Vue. To get started with Rails, you'll first need to have Ruby installed, then install the Rails gem and run Rails new. I'm developing this app on a fresh install of Debian Linux, and I did run into some issues with the initial setup. These were errors that could easily be solved with a Google search, but the initial setup was a little more error-prone than other frameworks. Once you get the project set up though, the Rails CLI is extremely powerful. Not only does it do things like serve the application with Rails server, but it can also generate a ton of code for you automatically with commands like scaffold. Now, if we look in the file explorer, you'll notice a bunch of different folders here, and that's because Rails is a batteries included framework. It handles your relational database, testing, logging, and a bunch of other stuff. It might look pretty overwhelming at first. Your main application code is contained in the app directory, where you'll find folders for models, views, and controllers. The first thing we'll look at is routing in the routes.rb file. From this file, we can map URLs to actions in a controller. Resources create all the routes we would need for a basic CRUD feature automatically. It's kind of magical, but what it's actually doing is setting up a mapping between URLs in the browser and controller actions. Now, when the user visits a URL, it will trigger one of these actions on the server. That action might go and retrieve some data from your database. The logic for that data is contained in the model. But before we can use the data in the database, we need to run a migration, which will take the code in the model and sync it up with the actual database. And all the data is managed with an object relational mapper called ActiveRecord. And then finally, you have a view, which is an HTML.erb file. ERB stands for embedded Ruby, and it allows you to render your data dynamically inside an HTML file. Overall, this provides a very nice separation of concerns, and Rails is very opinionated, which means you can achieve a lot of functionality with very little code. The scaffold not only retrieves items from the database, but it also provides UI to create and update that data as well. But too much magic can also be a bad thing depending on who you ask. And Ruby is not the most popular language in the world, but Python is. What if there is a way we could build web apps like this with Python? And that's where Django comes in. It's also extremely popular and has been used to build massive sites like Spotify and Bitbucket. When you generate a new Django app, you'll notice the file structure is far less overwhelming than Rails, but at the same time, it's still very much a batteries included framework. In addition, your code tends to be a lot more explicit. For example, we have this manage.py file that contains the code for the actual command line interface to generate things in the project. We could use it to serve the app locally or generate an app to represent a feature of the website. It also follows the MVC architecture, with routes being defined in the urls.py file, and controllers are represented as Python functions in the views.py file. A route points to one of these functions, which itself might want to access data from one of our models. A model is a Python class that represents the structure of data in an SQL database, aka the object relational mapper. And finally, we have our HTML templates that allow you to embed Python directly into the code. That's pretty cool, but one extra superpower of Django is that it has an admin feature built into it directly. As you define models in your application, you can register them with the admin app to easily manage all of your data in the browser. This is really useful and not something that you'd want to roll out on your own. Python's great and all, but the original server-side language of the web was PHP. There have been countless PHP frameworks over the years and high-level tools like WordPress, but the most popular one today is Laravel, the PHP framework for web artisans. To use it, you'll first want to install PHP and a tool called Composer. When I generated my initial app, it took a long time and downloaded a lot of packages. And as you can see, the initial project has a lot of batteries included, even more so than Rails. If we look at routes, you can see it not only handles web routes, but also API routes and channels for real-time communication with WebSockets. Now, if we go into the app code, you'll notice it's already been configured with things like user authentication via providers. A provider is like a shared service that you can use anywhere in the application. In the HTTP directory, we will find our controllers, and just like Rails, we have a class that contains a bunch of different methods that can access data and render a specific template. Now, our database models use a tool called Eloquent ORM, which is based on the same active record pattern as Rails. Now, when it comes to views, PHP is a language that's designed to work with HTML out of the box. Laravel makes it even easier by building on top of PHP with Blade templates. Another cool point about the ecosystem is that they put a lot of thought into how to integrate front-end frameworks like React and Vue. It has an adjacent tool called Inertia that can bridge the gap between front-end and back-end frameworks. The next framework we'll look at is Next.js, which allows us to build a full-stack application entirely with JavaScript. Now, in the JavaScript world, there's a million different options we could have chosen here, like Nuxt.js, Angular Universal, SvelteKit, Nest.js, Adonis, and many others. Maybe I'll make a top 10 video just for those. To get started with Next, we run npx create next app, and that will generate a starter project. Now, the one thing you'll notice about Next right off the bat is that it doesn't provide any integration for your database. There are a million different solutions to choose from, but one of my personal favorites is Prisma, so I'm going to add Prisma to this project. The fact that Next.js doesn't have a database out of the box is a good thing in my opinion. The JavaScript ecosystem is just way too crazy. It's nice to start with a very good minimal framework and then add whatever database integration you want on top of it. Now that we have a database integrated, let's take a look at the pages directory. One thing that's different about Next is that routing is handled with the file system. Each file defined in the pages directory defines a different URL in the browser. Dynamic routes can be created by wrapping the file name in brackets. Now each one of these files exports a React component to define the UI or view. This is actually really convenient because many other frameworks will ultimately want to have some kind of front-end framework. Having React fundamentally integrated into the framework can streamline your productivity big time. Now things get more complex when you think about data fetching. Normally in a React app, you're thinking about client-side code, but in Next.js, you can also run server-side code with functions like get server-side props. This function will run on the server with Node.js, and as you can see inside of it, we're using Prisma to fetch some items from the database. These items can then be delivered as props to the React component where they're rendered in the UI. Both your server-side and client-side code is tightly coupled together, which may feel like a bad separation of concerns, but generally speaking, it actually works very well. Overall, Next.js feels very minimal compared to other frameworks in this list, but it does a ton of stuff behind the scenes to simplify the annoying parts of web development. Now, speaking of simple, we're going to do the polar opposite and see what Java has to offer. Even though Java is a boilerplate-driven language for writing instant legacy code, the Spring framework actually makes it very enjoyable to work with. The first thing you'll notice when building with it is that it's kind of like a create-your-own-adventure story. It has a generator that allows you to start with a framework, and you can even use Kotlin or Groovy if you'd like. Then you choose all the different dependencies that you want to add to this project. Now, even though Java does have a lot of boilerplate, the code pretty much writes itself, and in my opinion, it feels a lot more robust compared to the dynamic languages that we've looked at so far. You'll find the source code way down in this deeply nested folder, and it also follows the MVC pattern. The controller is a class, and a route is defined using a decorator on each one of its methods. Spring relies on a lot of metaprogramming to keep your code nice and simple. It feels very much like Angular in the JavaScript world. The database models are based on code with the Java Persistence API. Then we can use that data in templates using TimeLeaf, where you add these attributes to your HTML to define where your data should go. To be honest though, I didn't have a very good time using TimeLeaf, and that brings me to Java's arch nemesis, C# and the .NET framework, or ASP.NET. It's an open source project maintained by Microsoft, and obviously feels very Microsofty, but is extremely popular and reliable. It's evolved very nicely over the years and has modern supporting libraries like Blazor that allow you to build client-side apps using WebAssembly and C#. To use it, install the .NET SDK, then generate a new MVC application. I really like the initial project structure. Everything is clearly named and it's not too overwhelming, and you get all the awesome tooling and static typing like you do in Java. When it comes to routing, the URLs are inferred from the class names in your controllers. Here we have an animals controller, which gives us the animals URL. Then we have methods in that class that then represent the next URL segment. The method can take an argument to create a dynamic URL. To represent our data, we have a model that is managed by an ORM called the Entity Core Framework. And then finally, we have our views, which are written in CS HTML. At the top of one of these files, you'll notice a model where we can access our data, and we can also declare additional data here in C#, like a title. It's more verbose than other templating languages, but you get full IntelliSense inside of it, which is really helpful. Overall, .NET is really impressive. The only real drawback is that you have to sell your soul to the big giant tech corporation. If you want to take the righteous path, another awesome framework to check out is Phoenix, which is based on the Elixir programming language. It's a functional language that feels much different than most of the object-oriented languages that we've looked at throughout the video. Don't worry, a 100-second video is coming soon. Install it, then generate a new project. Like Ruby on Rails, it has a very powerful CLI that can automatically scaffold an entire CRUD application for you. Routing is also very similar to Rails, where we have resources that map all the necessary CRUD URLs to the controller. In the controller, we have functions namespaced under a module that access data and render the appropriate template. The model uses an object relational mapper called Ktor, and templates use embedded Elixir, which again feels very similar to Rails. However, Phoenix has a huge advantage in performance because Elixir is a compiled language. As an added bonus, every app has a built-in live dashboard to closely monitor performance. And that brings us to another high-performance framework worth checking out, Djinn, which is powered by the Go language. It easily wins the Best Logo award. To get started, we're not going to use a fancy CLI, but instead create a Go project from scratch. Djinn is a minimal HTTP framework and is not concerned with the model view controller architecture. We'll have to figure that out on our own. It also doesn't contain an ORM for the database, so for that, we'll bring in another package called Gorm. The nice thing about this approach is that we don't really need to follow the MVC conventions of a framework, which is probably overkill for many applications. Instead, we can write some very focused functions and do things in a way that makes sense for our exact business needs. Like in this app, we just have two routes that need to retrieve some data from a database, which itself is modeled with a struct using the ORM. Then Go has its own built-in templating language, so we can simply create a couple of template files here in the project and interpolate the values that we retrieve from the database. The end result is a much smaller code base with a lot more low-level control. However, as this application grows bigger, it's going to get harder and harder, so you really kind of have to know what you're doing. And that brings us to our next language, Rust, and the web framework Rocket. As far as I know, the Rust ecosystem doesn't have a full-blown MVC framework like Rails, and to be honest, I found it very difficult to build a basic application. My approach was to use Rocket for HTTP and routing, then combine it with Diesel, which is a Rust-based ORM, and then finally a templating language to use the data in HTML called Ascama. I think this is a reasonable approach, but I didn't quite get to a full working demo with Rust. It's a systems language that gives you low-level control over memory, which the average web application developer doesn't really need. I quickly realized that it would take more time and dedication than I'm willing to give for the tail end of a silly YouTube video. However, there is one Rust-based library that I want to bring to your attention called U. It's a component-based framework for building web apps with WebAssembly, and it's coming to a Fireship tutorial near you soon. And that brings us to the final framework in this list, Vapor, which is based on the Swift programming language. This is the only app that I built on my Mac because I found that anything with Swift just works better on a Mac. It provides you with a project structure that looks like this. It's well organized with controllers, models, and routes. Routes point to methods in the controller, which can access data from a model. It uses an ORM called Fluent, which uses classes along with decorators to model your data. Swift is a very well-designed language, and I found it very enjoyable to work with for stuff like this. The code is concise and readable, yet statically typed with awesome tooling like you would get in Java or C#. I also like how it embraces async await when fetching data from your models. For templating, it has an engine called Leaf, which also felt very modern and practical. Now that we look at Vapor, I want to also mention Ktor, which is a Kotlin-based web application framework. It's a lot more minimal than something like Spring, but also something worth checking out. And with that, we've looked at 10 full-stack frameworks. Now I'm ready to show you the best full-stack framework in the world. You're looking at your own reflection in the mirror. Yes, it was you all along. Without you, the framework would be nothing. Actually, no, that's just dumb. Ruby on Rails is by far the best framework. Nothing else even comes close. It's like the Magic Jordan of web frameworks. Thanks for watching, and I will see you in the next one.